assignment. First of all, question 1. Question 1 is talking about it has passed the following temperature measurements taken from 7 a.m. till 12 p.m. but it has some missing data at 8 a.m. and 10 a.m. perhaps because of equipment malfunction. Then, by using a plot of this data, which the data connected by lines, we can lead us to estimate by interpolation the temperature at 10 a.m. and at 8 a.m. We can read the value from the line that connects the data points at 9 a.m. and 11 a.m. and hence we can estimate the value of the temperature at 10 a.m. In general, the more closely spaced the data is, the more accurate the interpolation will be. That's why plotting the data sometimes helps to judge the accuracy of the interpolation using straight lines to connect them. So here, given the interpolation, given the point x naught, y naught, x1, y1 until xn, yn, we can find the value of y if we don't have the value of x, just by using the graph and the connected lines. And now, by using MATLAB, we should just define the variable. That's right. It's shown question 1, then define the variable f print at question 1, then plot the time at 7 a.m., 9 a.m., 11 a.m., and 12 a.m., while the temperature respectively is at 49 degree Kelvin, 57, 71, and 75. So at T naught is going to get the T1, which is 7 a.m., and the small t, and for the small t1 equals to T at 2, which is 9 a.m. Also for line number 13, capital T1 is equal to capital T at 2, which is 57 degree Kelvin.
Now I will talk about the linear interpolation. So first method that we're using is linear interpolation. This is the formula of linear interpolation, which is f1 x equal to b0 plus b1 multiplied by x minus x0. So now, b0 is equal to function of x0 and b1 is equal to function of x1 minus function of x0 divided by x1 minus x0. So now I will talk about the linear interpolation, which is using T1 and T2 as reference point, and we want to find the solution at t equal to 10, small t equal to 10. So by x minus x0 multiplied by x minus x1, b0 is equal to function of x0, and b1 is equal to function of x1 minus function of x0 divided by x1 minus x0. And b2 is equal to function of x2 minus function of x1 divided by x2 minus x1, and minus the whole function of x1 minus function of x0 divided by x1 minus x0, and then divided by x2 minus x0. So using the quadratic interpolation, using small t1, small t2, and small t3 as reference point, we want to find solution at small t equal to 10. So b0 is equal to capital letter of t1, b1 is equal to big T2 minus big T1 divided by small t2 minus small t1, and b2 is also equal to big T3 minus big T2 divided by small t3 minus small t2 minus big T2 minus big T1 divided by small t2 minus small t1, and then the whole divided by small t3 minus small t1. So the temperature 2 is equal to b0 plus b1 multiplied by time 1 minus small t1 plus b2 multiplied by time 1 minus small t1 multiplied by time 1 minus small t2. So the f print f, by using method 2, when time is at 10 am, temperature is this whole sentence will appear at the command window. So now I pass the mic to Simi.
Hello, I'm Simi. So I'm going to explain the third method, which is Newton interpolating polynomials. So from the slide we can see it's actually F3 and we are using 4 reference points. So in this case we are using the TO, T1, T2 and T3 as reference points, which means we use all the data, which is 7, 9, 11 and 12 as the reference point. So the formula is given by, as the slide you can see, CO is equal to temperature O, and then C1 is temperature 1 minus temperature O divided by T1 minus TO. So we have to solve out the three solutions of the C1, C1A and C1B, and for the C2, which means we have to use 3 of the reference point, which is, we can straight away use C1A minus C1 and divided T2 minus TO, which is 11 minus 7. So CA2, which is C1B minus C1A divided by T3 minus T1, which is 12 minus 9. And then come to the last formula that we use. We use all of the reference points, which is C2A minus C2 divided by T3 minus TO, which is 12 minus 7. So the formula of the temperature tree is CO plus C1 times the time 1, which is 10, minus TO, TO is 7, then plus C2 times time 1 minus TO times time 1 minus T1, and the last plus C3 times time 1 minus TO, time 1 minus time 1, and time 1 minus time 2. So we will write up the printf by using method 3 when the time is at 10 am, temperature is then insert with the given formula inside. Then next I will say about we will start to do the graph plotting for the time underscore new one, which is T9, because we want to find the value of the 10. So at 10 am, so 10 am is time 1 in our end file, so we just insert time 1, then 11, 12, then for the temperature of underscore new one is 49, 57, and same temperature 1, 71 and 75. So next, and for the temperature data with quadratic interpolation, just now is the temperature data with linear interpolation. Then for this one is quadratic interpolation, and just change the temperature 1 to temperature 2. And for next one, this one is Newton's interpolating polynomials. So same, just change the temperature 1 to temperature 3. And last, we will write up the script for the graph plotting. We want to plot the temperature data to compare the linear interpolation with the other interpolation. So we write out the figure 1, which is our graph. Then we plot T new 1, means time new 1 with temperature new 1. Then we use R, which is red line. Then T new 1 with temperature new 2. We use K, which is black line. Then T new 1 with temperature new 3. We use B, which is blue line. Then our X label is time, our Y label is temperature, F. Then we put the legend, which is, we want to list out the line. Is linear interpolation, method 1, and quadratic interpolation, method 2, and Newton's interpolating polynomials, which is method 3. Then we put on grid. So this one will be our graph. So as you can see, there's 3 lines. For the blue one and the red one is quite close together, and for the black one is quite far further from them.
So after clicking run, we can get the answer from the command window. So by using method 1, when the time is at 10 am, the temperature is 64 Fahrenheit. So followed by method 2, the temperature is 65 Fahrenheit. Then method 3, the temperature is 64.3 Fahrenheit. So from the answer, we believe that the answer of the method 3 is more accurate than the other 2 methods, because it is Newton's interpolating polynomials and it takes more reference points than the other methods. So that's all for our presentation. Thank you.